Afternoon, and for the first time in the history of the universe we've got a lighting looking actually reasonable. It's a bit crude, but it's working. Back to the Arduino. Yeah, update. I've played with the serial port thing, the shift register. Yeah, it works. It's, there's sample files within the Uno, the Arduino Uno library to play with, and they make LEDs chase basically. One of them's quite fun. It counts from 0 to 255 in binary, which is quite good. It's entertaining, but it's not exciting enough to make a video out of when you can do it yourself so easily. And I got distracted and I found, oh look, oscilloscopes for Arduino. So I'm going to move the camera around. We can look at the computer and play with that. Let me get a cursor out of the way. This in the background is the wallpaper, don't worry about it. This is, again, reading or writing to the serial port and displaying that on the serial plotter that's included in the Arduino. So that bit's easy to set up, and it's a very short bit of code. If we dig up the code, that's it. It's all there is. The void setup is serial begin, and in this case it's quite a high baud rate. And then the loop is an integer value which equals the analog read from, in this case, port A1. And I set it up as port A0 because that's what all the others do, and couldn't work out why it didn't work. Hang on. Bit of bug finding. And then serial print the value that port's reading. And that's it. And then you get that. Now there's no adjustments on it. You can't alter the time base. You can't do much. You use 2 bits of wire. There they are. One to ground and one to the analog port. I can, if I bridge them together, not a lot happens actually. Oh, there we go. We get a good contact. We can actually get the line steady at 0. And yeah, if it's running like that, and I put 1.5 volt cell across it, the input is limited to 5 volt, by the way. If you go more than that, your Arduino dies. Oh, look at all that. There's all interference. See, if I do that, it does, 1.5 volts. It clips off a lot of the interference. But it's still there. It's trying to be a flat line, but it's spiking. It's got a square wave dropping down under it, and yeah, it's a bit messy. I suppose we could try this. This is where the Arduino goes bang. We could plug the input directly into 3 volt, and we get that, which is messy, or 3.3 volt, and if it goes into the 5 volt, we get a straight line. That's good. Go back to 3 for a moment and let it go. Reset it because I can. Yeah, it's spiky. We hold it. It changes slightly. It shows you're getting a waveform. It shows something's coming out. It's not particularly brilliantly useful. If you just need an oscilloscope to demonstrate a signal's present, then yeah, it's fine, and it's so easy to do. There are a number of other oscilloscopes available for the Arduino, which use this program here called processing in order to read a serial input and display it graphically, which actually it comes up with some beautiful graphics. That's the one that I've been working on. This is another simple oscilloscope running through processing. Can I get it to work? Can I? Insert expletive of your choice here. So I'll get rid of that one. Can I find another one? If I click open, and this one's really, really, really impressive. I think it might be that one. Let's find out. What does that say? I don't know how to open Sketch with INO as the extension file. Oh, okay. Be back in a minute. Okay, this is the other bit of software for the Arduino for oscilloscope. I'm going to tell you anything about it because it's quite exciting. But that's now uploaded, so we can get rid of that and we can come to the corresponding chunk for processing. These are free programs, by the way. Processing is a free program, and there are videos on the internet. We'll set that going once I talk about it. There are videos on the internet of just how well it works, and it works beautifully for everyone else. But this is me, isn't it? What's that coming up with? There we go. Look at that. 4-channel oscilloscope. I need to set the baud rate. I've forgotten what it is. Put that somewhere where it's going to be a bit obvious when this one leaps to the front. And of course the instructions are all in Spanish. I think that's Spanish. Yes, it is Spanish. I've tested it. It's Spanish. I think it's quite a high baud rate again. We'll try. So we set serial. Oh, we've got to set the COM port first. COM port 4 speed. I think it's that one. And then we turn it on. And where's my battery? Let's see if one of those lines leaps about a bit. And the answer is no. I will try a trigger. And the answer is still, well, I might be trying the wrong trigger. Let's turn them all on. Well, that one didn't. Oh right, they only come on one at a time. Fine, fair enough. No on the yellow channel. The channels are interestingly numbered 0 to or 0 to 3 rather than 1 to 4, which just makes life slightly more interesting. No. This one might. And no. Okay, it doesn't work. This is the problem that I've had with processing. Everything I've done in processing to talk to the Arduino doesn't. And it's very depressing. So that's our next project, is to find out why. I can show you a demo. When this one works properly, it does things like that. Or that. Or that. And it's got various tools to adjust. I think it's just the time base on it. You can certainly adjust the sensitivity. Bearing in mind that you cannot put more than 5 volts into an Arduino input. Yeah, I mean, it looks, if I can get it to work, it's going to be really flexible. If I can get it to work, there'll be a video on it because I'll be ever so excited. That's it for now. This is a new venture for quite a lot of people. If I find the solution to this, I will certainly make a video of it, and then we can all build oscilloscopes and not have any idea what to do with them. And if I can get the shift register to act as a multiplexer that runs in other than just an on-off state, so that we can pulse width modulate through it, which surely can be done. Someone will hopefully know. We're on the way to having lots and lots and lots of fun. So we'll see you all again soon.